In crime analysis, watch how fast we move. We geocode the incidents, we get our blanket of points, and then almost reflexively, we jump straight to the hotspots and the kernel density surface. Points to heat map in one iteration. But there's a step in the middle we often skip. Before you ask where the distribution burns hottest, you can ask what shape it has. Where's the center of gravity? How far does it spread? Which way does it lean? And has any of that shifted over the last 5 years? That's the descriptive step, and it routinely gets overlooked by students and seasoned analysts alike. Welcome to the Spatial Exchange. In this episode, we're talking about 4 descriptive measures that live in that overlooked middle and why jumping past them is a missed opportunity. Start with the frame. Any distribution of points in space has 4 basic properties you can describe. Central tendency, where's the middle? Dispersion, how spread out is it? Orientation, which way does it lean? And extent, how much ground does it cover? Ecologists use these descriptive tools regularly. Geographers, epidemiologists, even astronomers. Open a typical crime analysis, though, and you'll find hotspots and kernel density and almost nothing else. We typically just use half the toolbox. So let's build the shape, the middle first. The mean center is the simplest measure in the family. Average all the x coordinates, average all the y coordinates, and you get a single point, the balance point of the whole distribution, not the hottest spot, not necessarily even a place where a crime happened. It's the weighted midpoint, the center of gravity. And the real power of the mean center isn't one map, it's a sequence of them. Compute it week by week or month by month and watch it move. If the mean center of shootings drifts steadily east, that's something the hotspot map generally hides. The whole distribution is on the move, whether from displacement, redevelopment, or a shift in policing. You can also compare across crime types. Put the mean center of drug arrests next to the mean center of overdoses and ask whether enforcement is even aimed where the harm is. Now, the mean center has a weakness, and this is where the central feature becomes useful. The mean center is an abstract point. It can land in the middle of a river or in an empty lot because it's just the spatial average. The central feature fixes that because it asks a different question. Of all my actual incidents, which real one is the most central, closest to all the others? That gives you a true location in XY that you can stand on. I like using them as a pair. The mean center is where the math says the balance is. The central feature is the real place sitting closest to it. One is the abstraction, the other is the anchor. Now, we have a middle, but how tight is it? That's the standard distance. Think of it as the standard deviation you already know, but in 2 dimensions. It measures how far, on average, incidents fall from the mean center and hands you back a single number, a radius. Draw it as a circle and you've got a clean picture of compactness. And like the mean center, it's most useful in comparison. A small standard distance means the distribution is coiled tightly around its core. A large one is diffused, smeared across the map. Track that circle over time and you can watch a problem tightening into a hotspot or a suppressed one loosening and spreading out. That's a different story than the peak got hotter. It's whether crime is concentrating or dispersing, which is often the thing you actually want to know. And here's the one I find most interesting and the most neglected: orientation. The standard distance draws a circle which assumes crime spreads evenly in every direction. It usually doesn't. So instead of a circle, we draw an ellipse. The directional or standard deviational ellipse. It has 3 properties: its size, how dispersed things are, its shape, how elongated, a fat oval versus a thin one, and its orientation, the tilt, the dominant axis the events stretch along. That tilt is the whole objective because it captures flow. Crime pattern theory says crime isn't scattered randomly across a blank surface. It rides the built environment, the paths, the nodes, the corridors people move through. Offenders and targets meet where their routine pathways cross. So, of course, crime elongates. It follows streets, transit lines, commercial strips. The ellipse makes that flow visible. A burglary ellipse stretched along a north-south axis is showing you a corridor, not a coincidence. Biologists draw these same ellipses over migrating birds to capture the flyway. Marine ecologists use them to trace fish moving with the currents. The ellipse works there for the same reason it works here. It visualizes flow no single point can show. Fish follow currents, birds follow flyways, and crime follows the geometry of a city. So here's the takeaway. Before we reach for significance tests and prediction, let's describe. Find the center of gravity with the mean center. Anchor it with the central feature. Measure the spread with the standard distance, and read the flow with the directional ellipse. None of these tools forecast anything. That's not the job. The job is to make the shape of the problem legible. How it sits, how it's spreading, which way it's moving. It's a modest set of tools criminology mostly leaves on the shelf, even as ecologists and geographers kept using them every day. Pick them up, use them. This has been the Spatial Exchange. Go make some maps and describe the shape before you predict the future.